Now let's just move on further towards the new topic, which is nothing but the surface area of a right circular cylinder. So let us suppose if I'll just have this particular circle having the radius as r. So I'm just taking all such kind of the circles and I'm stacking them up in a vertical pile, and what figure then I will get at the end. So as you can see, if I'm just piling up or taking a stack of all of these and piling them up in a vertical pile, so basically I'm getting such kind of a figure, and this is nothing but called as a right circular cylinder. So in general we can say a right circular cylinder is nothing but of this type. As you can see, there is a height for this particular right circular cylinder. So let us suppose if I'll cut it along its height, so what will I get if I'm just talking about this particular section only? Means I'm just talking about this particular section, and if I'll cut it from this particular section, what will I get? Then I will definitely get a surface which is nothing but of this type. As you can see, if I'm just talking about its curved area, so if I'll just cut it along its height, then I will definitely get the area of such a type. So we can say that the curved surface area of a cylinder, I'm just talking about the curved area only. So the curved area of the cylinder should be nothing but is equal to the area of this rectangular sheet. As you can see over here, since I have just taken a cut out of this right circular cylinder from or along its height only, and I'm just taking the curved surface area. So when I'm just cutting it along its height, so I'm getting this kind of a plane figure, and this is nothing but area of a rectangular sheet, and area of the rectangular sheet should be nothing but is equal to its length into breadth. And here length is actually the perimeter of the base, because this section was definitely nothing but the perimeter of the circular base, and we know that the perimeter of the circle is nothing but 2 pi r. So hence if I'll just substitute the value of the perimeter of base as 2 pi r, so at the end what we are getting the curved surface area of a cylinder as 2 pi r h, where r is the radius of the base, h is the height of the cylinder. So this is all about the curved surface area of a cylinder. So always remember, the curved surface area of the cylinder is nothing but 2 pi r h, where r is the radius, h is nothing but the height. Now let's just move on further. Let's just further talk about the curved surface area being the 2 pi r h. Now further, if I'm just talking about the total surface area, means I'm talking about the total surface area of the cylinder. So let us suppose if I'm just taking up the figure of the cylinder. So this is nothing but a cylinder which is open from above. As you can see, this is the above area, this is the below area, and you can see over here that along with the curved surface area, a cylinder has an above area and a below area, and both these areas are nothing but the area of the circle, because above there is a circle and below there is also a circle. So hence what can we say about the total surface area of this cylinder? This should be nothing but is equal to the sum of the curved surface area and the sum of the above circular area and the sum of the below circular area. And we know that the area of the circle is nothing but pi r square, so there would be 2 pi r square. So hence the total surface area of a cylinder is 2 pi r h, means the curved surface area, plus the area of the top plus the area of the base, which is nothing but 2 pi r square, and at the end we can write it as 2 pi r into r plus h, where r is the radius of the base and h is the height. So this is all about the surface area of the cylinder, in which we have talked about the curved surface area, which is 2 pi r h, and the total surface area, which is 2 pi r h plus 2 pi r square, which can also be written as 2 pi r into r plus h.